All right. Good afternoon, Professor Lee. My name is Chris Berry. I'm here today to present to you the optimization of an AK-47. A little history of the AK-47. It was designed by Mikhail Klishnikov between 1941 and 1947. Approximately 75+ million units have been made since it was first released. And an interesting fact is Klishnikov has never made any money off of his design. Product evaluation, the first phase of design. What are the strengths of an AK-47? It's extremely reliable, very low cost, easy to manufacture, and has very low maintenance. What are the weaknesses? Here in this video, what you'll see is bending of the barrel. It's made out of flimsy, cheap material, and this actually can cause chipping in the barrel and flexing of the barrel, which creates inaccuracy of the weapon. So here, you can see as it shoots, there's a little bit of a bending in the barrel. Weapon handling. This here will show someone shooting the gun just one round at a time. You can see the kickback, which is problematic and also induces air in the weapon. Now you can imagine when you shoot a weapon, automatically that air is increased significantly. Design goals. My design goals are to increase firing accuracy, increase weapon handling, and increase weapon durability. Design phase 2. This is where I perform a design and survey of the weapon. Product comparison. Common comparison to the AK-47 is the M16, which is currently used by the United States government. There's also the AKM and the AK-74, but because there's so many similarities between the M16 and AK-47 in terms of their use, I chose that. The M16 has a heavier and thicker barrel than the AK-47. It also has a more compact design, which means there's less play in the weapon, which means it's more accurate. And it also has a lower recoil due to a buffering piston, as well as a smaller round, which means there's less of mass to shoot out of the weapon. Here is a video showing how the M16 shoots in automatic mode. And if you can remember the AK-47, there was a lot of kick when they would fire. And this is what it looks like when an M16 shoots automatically 100 rounds in about 10 seconds. So you can see here that there's pretty much zero kickback, and there's significant difference in the accuracy of the weapons. But the problem is with the M16 is that because all the components are NC machined, they are very accurate, which means they have to be taken care of, as opposed to the AK-47, which you could just leave in the ditch for a year and then use, or use in all kinds of different climates. Phase 3, project management and idea generation. Here what I did is I did just a general timeline, a Gantt chart of what I was going to do over the semester. I followed it pretty close. This here is the current recoil dampening system for the AK-47. It's basically 2 guide rails for the spring inside, and then that's loaded into the weapon, which I'll show in just a second here. It's a very basic design. And at the very right end, that's where it contacts with what's called a bolt carrier for the weapon. Alternate designs, because there's so much of a kickback, I wanted to create some kind of a dampening system for the spring. Here on the left-hand side, what I did is I kind of came up with some kind of an idea to work with the guide rails to work against this little cap at the end of the spring. And also I had on the right-hand side a sketch for a rubber dampening system, so when the bolt group comes back, it can contact with the rubber dampening system and significantly slow it down. Here's the current barrel and receiver assembly. Just flimsy, cheap materials, easy to make. An alternative design for this to reduce the bend in the barrel and the receiver is to increase the thickness of the receiver walls and also increase the outer diameter of the barrel itself. Design phase 4, component modeling. Here's a few images of some of the critical components. Here we have the bolt group, we have the buttstock there, barrel, the receiver, rear recoil spring guide, and what's called a front guide retainer, which goes at the end of the spring. Here's a little bit of an exploded view of critical assembly. This is how the receiver itself is mounted to the buttstock. Here's a full assembly of what I did. I omitted a few components. I did not do the clip just for time purposes. Didn't really go into this part of the study. I also omitted a gas tube and the safety mechanism, as well as covering plate. Here's an exploded view. To the right, there's a list of some of the components that I made that are shown here in this exploded view. Design phase 5, engineering analysis. On the current components, I did an engineering analysis. So what I did is I exerted a force at the end of the barrel, which would kind of simulate the kickback of the weapon itself. I performed what's called a frequency analysis of the barrel, which shows basically the flex of the barrel itself in its initial condition. I applied a rough mesh, created a joint at the receiver connection, which is basically where all the components are, where you fire the weapon. And I just applied a continuous force of 100 or 500 pounds on the end of the barrel. Here you can see the displacement on the left-hand side. It says it displaces approximately 1.5 inches. That's in the worst-case scenario. And there's 216,000 psi in the barrel itself at the max part. I also performed frequency analysis on the receiver, joined it where the barrel was, and also where the buttstock is, where all the contact points were, and showed the flexibility of that section. Here you can see the stresses, so I'm just going to blow through this real quick. This is the weapons handling. This is a simulation of what I did. Now, it's hard to see in the beginning because SolidWorks can't really accommodate how fast the barrel actually, or the bullet group actually moves back. But you can see it kicks back on the return phase after hitting the wall. That's where it loads the weapon, or the bullet back in for another firing. I have position, velocity, acceleration there. Redesign components, same thing, increase the thickness of the wall here, increase the thickness of the barrel, did the same analysis. You can see there's a displacement of only 1 inch as opposed to 1.5 inches, and I reduced the stress in the barrel significantly. Same thing here. What I did for the weapon handling is I induced the polyurethane dampener in SolidWorks. Basically, when the bullet group came back, smashed against that, reduced the recoil significantly. Here I have a velocity, position, acceleration breakdown of what's actually happening at the end of the barrel. The results, there's a 36% displacement reduction with a 15% increase in the outer diameter of the barrel, a 20% reduction in the mass displacement for the receiver with a 50% increase in the wall thickness. Actually, it's double in the wall thickness. And the barrel movement reduced a lot, which means the bullet will exit with a straighter trajectory and increased accuracy. Here's just a comparison. You can see here where the rubber dampener hits, so it breaks up the motion. It takes much less time for it to come to rest. Increase durability and reduce the stresses and the max stress in the system. And discussion, simulate the recoil, did the motion simulation, and basically that's it. Any questions?
Yeah.
Go ahead.
You said accuracy, improvement of accuracy.
Yeah.
So you have done the bending and the recoil, right?
Yes.
But when you fire one bullet, the bullet is gone already ahead. How are you improving the accuracy?
Well, because it's going to obviously be amplified once it leaves the weapon. So if it's leaving with 0 displacement in the barrel location at the end of the barrel.
No, the bullet is already gone ahead.
Yes.
So how is the accuracy improved? When you're bending is the after effect. You see it as an impulse, right?
Right. There is still displacement when the weapon's firing. There's still, it's instantly as soon as the weapon's gone.
You're improving accuracy for like 10 bullets, like 100 bullets. For one bullet, I think accuracy is the same.
I'm not quite sure. I didn't really do a study on that. That could be true. Any other questions? Okay.